Welcome to aminacademy.com. In electrical engineering, let us discuss about resistors in parallel. Resistors are said to be connected together in parallel when both of their terminals are respectively connected to each terminal of the other resistors or resistors. Resistors in parallel formula. Here, look at this. Here three resistors R1, R2, R3 are connected in parallel circuit with voltage V. Here the total current is I. Now here in parallel circuit we know that current is distributed. So first I is equal I1 plus I2 plus I3. Then we know that by Ohm's law I equal to V over R. Therefore, I1 is V over R1 plus V over R2 plus V over R3. Now, I equal to V by R or equal V over R1 plus V over R2 plus V over R3. Now take out V common and cut. Therefore V by R equals 1 over R1 plus 1 over R2 plus 1 over R3. Then V and V cut. So we have generally 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. Here this is the effective resistance. From that we can find, taking LCM and add it and find the reciprocal, we can find the effective resistance. Here resistors offer resistance to the flow of current in a circuit. The effective resistance depends on their connections, whether it is connected in series or parallel. In a series connection the current will be constant, whereas in the parallel connection voltage will be constant through the circuit. So in household appliances parallel connection is preferred because we can operate individual appliances with individual switches. The formula for resistors in parallel connection is, we derived here 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Generally we can write 1 by Rp, that is effective resistance, is equal to 1 by R1 plus 1 by R2 plus 1 by Rn, whereas R1 and R2, R3, Rn are the resistors connected in parallel. Here characteristics of a parallel circuit. Each resistors join the same two spots. The circuit total current is split between the parallel branches. The sum of the current in the parallel branches equals to the total current in the circuit. The overall resistance of the circuit decreases as the number of branches grows. Next, look at this some example. Calculate the resultant resistance of a parallel circuit containing three resistors, R1 equal to 2, R2 equal to 4, R3 equal to 6. Look at here, these individual resistors are given. The formula is 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. By using this formula, we can get Rp equal 1 by Rp you have to find by taking LCM and add, and reciprocal at find Rp equal to 1.0909 ohms. Calculate the next question. Calculate the total resistance of the given parallel connections. R1 is 4, R2 is 5 ohms, and also find the current of each circuit if circuit voltage is 100. Here R1, R2, R1 and R2 is given. The formula is 1 by Rp equal to 1 by 4 plus 1 by 5. That is 1 by Rp equal to 9 by 20 by taking LCM and cross multiply. Rp equal to 20 over 9. Then we can find the current of each resistor. So I1 by using Ohm's law, I1 equal V by, here V equal to IR, we need and also find the current. Therefore I1 V1 over R1. V1 is 100. In parallel circuit, every resistors have same 100 over R1 is 4 ohm, which is equal to 25 amps. The second I2 equal V by R2 is V2 or R2, which is equal 100 by 5, 100 divided by 5, which is equal 20 amps. So far we have done resistance in parallel and its formula, and also we did 2 example problems. We have done. Please subscribe our YouTube channel.